Early morning hustle. My screen pod just stopped recording because I reached my 15-minute max. Such is life. Let's get back to it. So, type 2 error is the idea of failing to reject the null hypothesis. My apologies. Failing to reject the null hypothesis. And once we fail to reject the null hypothesis, there's a possibility that we could be making an error. And that's called a type 2 error, meaning that we are saying that the null hypothesis is true, right, based on the data, but in reality, mu is actually greater than 35. Mu is actually greater than 35, and our sample didn't detect it, okay? Because from sample to sample, we know for a fact our sample mean and our standard deviation is going to be different. Our will change, right? So therefore, this particular sample could just be a bad sample, and based on the real population, mu is greater than 35. The garbage in that county is a lot. They got a lot of gifts. Okay, we just got a bad sample. There's a likelihood of us making that mistake. Okay, and so it's imperative that we are aware of that. Okay, so what's interesting, and this is going to be a little bit counterintuitive. Let's say I need to add this to this problem. Let's say that it's two-tailed. We need to make that little small distinction. Let's say that it's two-tailed rather than one tail, right? So it means that this is a two-sided test. If it's a two-sided test and mu is equal to 20, what do you think is going to happen to that test statistic? Okay. That test statistic, right, is going to go from negative 0.905 all the way to the right. All the way to the left. All the way to the left. It's going to get really, really, really small. It's become smaller than negative 1.17. It's going to be really, really small. And since in that situation it's two-tailed, right, it's going to be a one, if we assume a 90%, 0.1, this would be negative 1.717 and still 1.717. We're going to be in the rejection region to the left, right? So therefore, my p-value is also going to be very, very small. Okay, so if mu is equal to 20, we're going to reject that null hypothesis. So if you were to do the math, 32.725 minus 20 divided by 2.54, you get 5. Sorry, we're going to be to the right. My apologies. If you caught that earlier than I did, my apologies. We're going to be to the right. So the mu is equal to 20. We're going to be all the way to the right of this distribution, over here to the right. Okay. So if mu is equal to 20, we're going to reject the null hypothesis. That's only in the situation at which we had a two-tailed test. Okay. So you don't have to. You can put in the comments. That'd be nice in the comments. How difficult was that? Was that a 1 being really, really easy, or a 5 being crazy difficult? Crazy difficult. Put in the comments. So that'd be cool. What we're gonna now do is talk about this p-value thing. Okay. So here, the p-value is measured. Is a measure of the probability of the null hypothesis being true given the actual data. Okay, given that we actually have this data. Okay. And so how I think about it is by thinking of coin flips. If you flip a coin 4 times, right? So you flip it once, it's going to be 0.5. Flip it twice, it's 0.5 squared. Flip it 3 times, 0.5 to the third power. Flip it 4 times, it's going to be 0.5 to the fourth power. This is the likelihood of us flipping heads 4 times. Is this likely? I would argue that this is unlikely. This is 6% of the time of this actually occurring. Okay, this is a very unlikely occurrence, and I just feel like, but it's more like if a p-value is smaller than, let's say, 0.6, this is a really unlikely event. Let's say, for example, we're getting a probability that's even smaller than 0.06. Let's say it's 0.00001. That's a really unlikely event to occur. So the smaller the p-value, the more we can think that this null hypothesis is really unlikely. Okay? And so what we're going to do in this class is that once our p-value is less than 0.1, we reject it. We're just going to reject it. We're just going to flat out reject that null hypothesis. And the smaller that p-value is, the more evidence we have against the null hypothesis. Okay, so here between 0.05 and 0.1, we have some evidence. We have a decent amount of evidence, but not a lot, but we have some. Okay, if it's in between 0.01 and 0.05, we have fairly strong evidence. In between 0.001 and 0.01, we have very strong evidence. If it was less than 0.001, we have extremely strong evidence that against the null hypothesis. We don't know that it's true. We can't say true or false in the situation regarding the null hypothesis. We're just talking about the amount of evidence we have against it. Okay? Well, that is all for this video. Thank you, and stay tuned for the other two.